and thank you for tuning into episode 3 of the Light It Up podcast. On today's episode, Tom had the pleasure of speaking with Terry McGowan, the Director of Engineering for the American Lighting Association. Terry is an absolute wealth of knowledge in all things lighting, and we could not be more honored to have him come on the show. Before we get into the episode, I just wanted to let you know that around the 42-minute mark, our call with Terry had dropped out. We resumed recording the interview the following day, so if you hear a blip in the audio or any redundant information, it's just us. Anyway, I'll pass it off to Tom now with the interview.
Well, again, thanks, Terry, for being our guest at Light It Up podcast. I just wanted to let everybody know that this is a neutral-based podcast revolving strictly around education. No particular company is going to be called out or, sponsoring us. It's strictly about educating everyone from the consumer to the contractor about everything that's going on with lighting. Especially we get into all of the LEDs. There are some things that aren't as transparent as we'd like. So we're here to just help answer those questions. So with that, Terry, I'd just like for you to tell us a little bit about yourself and your experience in the lighting industry.
Well, I've certainly been in the lighting industry going on 50 years now, so it's been a long time. I came right out of school in electrical engineering and went with GE Lighting in Cleveland, their headquarters location, and started in photometry and then moved into technical marketing and application engineering, and finally retired from there after some 38 years and started my own business in consulting called Lighting Ideas, and was fortunate enough to get some contracts that were really interesting at the time because they were just leading edge stuff. One was with the Electric Power Research Institute, or otherwise known as EPRI, and I managed their lighting research office for several years, so that put me into the lighting research arena. And then, of course, in 2001, American Lighting Association was interested in having a technical person on staff. Someone was retiring, and so I've been their Director of Engineering and Technology since 2001. So it's been a very interesting ride, a long one, but it also has really reflected the transitions that the lighting industry has gone through all these many years, from the days of fluorescent and high-intensity discharge lamps to the days of LED lighting. And so that's been a wild ride in many respects, and certainly one of the more interesting times to be in the lighting industry, and I've enjoyed every minute of it.
No, I bet. That sounds like a lot of fun. So when you got started in the lighting industry, what was some of the new technologies back then?
Well, at GE Lighting's headquarters called Nela Park, virtually all the technology that was involved in light sources at the time was being invented there. I came in a period where the fluorescent lamp was king and queen and everything else. Fluorescent lighting was it. Even fluorescent lighting, and not too many people remember this, was used for lighting roadways. So if you can imagine long fluorescent tubes and great big fixtures over a roadway, that was pretty impressive. And that applied to State Street in Chicago and interstate highway interchanges and various things. It was really something to behold.
Oh, I bet.
But right after that, of course, along came high-intensity discharge lamps, mercury, metal halide, and high-pressure sodium. And they transformed that whole area where lots of lumens were needed at high efficiency. And so those light sources very quickly overtook fluorescent, and it became kind of a new era in lighting of high-intensity discharge sources.
So when you started at Nela Park, if we go back 50 years ago or so, that was about the same time that the MR16 was being developed, wasn't it?
Yes, and not many people know some of that history, but the MR16 started life as a developmental halogen incandescent lamp for Kodak. Kodak carousel projectors used it in the early days. And then all of a sudden, lighting designers started to look at it, or lighting engineers at the time. There wasn't really a design community. And all of a sudden, they fell in love with it. And so there got to be great lines of MR16 lamps with little halogen filament tubes. And those came in various wattages and light distributions from narrow spot to wide flood. And all of a sudden, it was a line of light sources that was small, bright, could project light, could be used in track fixtures and spotlights and downlights and just about everything. And so the MR16 really revolutionized accent lighting and, well, many applications of the time. But the interesting part is that the designers got hold of this and they could really understand it. And so they started using it for everything, from general lighting to accent lighting to museums and displays and everything else. And out of that really was built the lighting design industry as we kind of know it now. GE had a competition called the Edison Awards, and the Edison Awards rewarded people for using those new light sources, and more people got into lighting design. The New York lighting community was kind of leading the way for using people from the theater, and they became lighting designers and very broadly beyond the theater and into applications as offices and schools and stores and buildings and so forth. And all of a sudden it exploded. And now, of course, there are thousands of lighting designers, but not only was the time ready for that, but also the products were ready. And they certainly supported the growth of that bit of the industry that we know today.
Right, I bet. If my memory and history serves me correct, I want to say that was somewhere around 1969. Is that correct?
Yes, your memory is very good about that. It was mid-60s to mid-70s when we saw all of that. And yes, at that time, halogen lamps were replacing the standard incandescent. So there was lots of unusual products, linear and par-type lamps, reflector-type lamps, and little bitty grain of wheat bulbs, and all kinds of things to play with. And the designers took full advantage of that.
So right after, or how long after, the halogens, the MR16s, and all that, was UL able to catch up with all of the regulations for heat and I can just imagine, what's going on there.
Oh yeah, the halogen lamps were very hot, and you couldn't even touch them. It would really burn you if you happened to hit the surface of a halogen lamp. So halogen lamps were then enclosed in outer glass structures that helped. But as you say, because so many watts could be packed into such a small package, there was a heat problem. And connectors and sockets and various other devices had to be redesigned to take that extra high temperature. And of course, there was the safety aspects. So UL was busy revising their standards, the major standards that apply to lighting fixtures. And eventually, those were all brought up to date. And of course, the product had to be safe and electrically safe and fire safe. And so that required quite a bit of work on the part of the code panels.
Sure. Okay, so here's a myth buster question. A lot of people today still say that, the halogen lamps back then couldn't be touched by human hands or fingers because of the oils would cause. Is that a myth or is that a fact?
Well, let's say it's partially a fact because indeed, if you used your fingers to install a halogen bulb in a fixture, you'd get fingerprints on it, skin oils, and so forth. And at the high temperatures, those oils would burn or oxidize, and it could pit the surface of the quartz. It could take a clear quartz surface and make it slightly frosty. So maybe the optical characteristics would be compromised in some way. But it was a very rare situation where that kind of handling would cause the lamp to fail early. It was often more of an optical problem than a life problem. And I never saw a lamp that failed because it was full of fingerprints. Let me say it that way. I did see some that were quite a bit different than when they started out, because they were fogged up and had patterns on them and that kind of thing. But no, it was more myth than fact.
Okay. Putting a little bit of science and engineering into it, that's kind of what I suspected, but I thought I'd go right to the source.
Yeah, that one's been around for a long time.
Yeah, and you even see the little halogen lamps come in and with foam packed around them and please don't touch and all that. So that was pretty crazy. So over the years, you've seen a lot of changes, obviously, in the lighting industry. What do you think one or some of the most challenging changes were there to overcome?
Oh, well, of course, the lighting industry always loves new things, and they like to develop new products and new applications. In residential, of course, appearance is everything, and it's always a kind of a tug of war between, is this lighting to see by or is this lighting to look at? And that was a phrase that was used by a lighting company for many years. The company was Lightolier. And it really works today, because at one extreme or the other, lighting doesn't work very well. You have to find that sweet spot between lighting to look at and lighting to see by that really suits a given application. So that's been a constant battle with the technology, and adapting to the technology at hand and applying it to practical lighting applications that do the job for people. Because when it's all said and done, lighting is for people. And they are the ultimate reason why lighting is put in and designed the way it is. And if you can maximize that, everything else can be dealt with. Efficiency, color, brightness, glare, all of those good things that we know about lighting and have to be controlled and considered. But really, you have to really make the people understand the lighting, be happy with the lighting, be satisfied that it's doing the job it was intended to do.
Right. What about technical challenges with all these new technologies coming out with 12 volt and HID and all of that? What about, all of the drivers and ballasts and all of that? Was that pretty critical as well?
Yeah. What we came up with, and you mentioned the MR16 a while ago, that was a 12 volt lamp. And so for the first time, really, for general lighting, we had to put low voltage into fixtures. How should we do that? Should this be an old transformer, traditional transformer, or should it be an electronic transformer with many more parts, but very light, very small, maybe built into a bit of the fixture? There were all these challenges at the time. And then if you had different circuitry feeding the lamp, how do you dim that lamp? And so dimmers had to be engineered and designed to do that job. And dimmers, of course, were pretty big, bulky items. When I first entered the lighting business, they were auto transformers. I don't know how many people remember that name, but it was a variable auto transformer. So you had this great big box on the wall weighing several pounds, and you stuffed this auto transformer dimmer into it and dimmed the lamps. It worked beautifully, but it was just big, heavy, and expensive. So along came the electronic dimmer, and that was a revolution in itself, because it was a very nice way to dim a lamp, but it came with its own problems, such as it wasn't particularly robust against inrush current of an incandescent circuit, for example. And so the early ones burned out quickly if they were overloaded. And then there was radio interference problems because they changed the waveform, and that reflected back into the wiring of, say, a home. So there are all these little problems that cropped up along the way that really weren't direct lighting problems, but they had to be resolved in order for the lighting to utilize the technology.
Sure. Was even electronic transformers available back in late 60s?
No, they came along much later as we began to get into transistors, first of all, and some of the electronic circuits that could be built on a chip, because size was very important in order to really be better than the old auto transformers and variable voltage auto transformers. They had to be small and light, withstand heat, a little bit of bumping around perhaps, and uh, that took a while in terms of electronic design.
Right, right. So one of the main points that I want to discuss today was lighting and how our health is affected by it. Now I know very little about this subject, and just things that I have heard off and on here. So one of the things that is one of the things that I had heard some time ago was this thing about circadian rhythm. Did I say that correctly?
Yes. Yeah,
So
you
what is
certainly did.
so what is circadian rhythm?
Well, circadian rhythm is a cycle. That's why it's called a rhythm. And it applies to really all living things, but certainly to human beings. And human beings are designed and have adapted to periods of light and periods of dark. And a simple way to say it is people need bright days and dark nights. And if you think back into human history, that's been pretty much the way it has worked for many thousands of years. So now, in this age of electric lighting and even more lighting at night or screens or other bright objects in your field of view, that lighting pattern has changed so that we live more in a kind of a twilight world, maybe even 24 hours a day. And those people who work shifts, like from midnight to 6 in the morning or something, their exposure doesn't at all jibe with what traditional nature has provided. So things get messed up, and what gets messed up is the circadian rhythms, what the body expects to have in bright dark night cycles can be changed. In a way, it's a little like getting on an airplane and traveling over several time zones. Your body clock has to be reset when you land and get used to the place where you are. Otherwise, you are your time cycle is changed, not for the good usually, but you have to recalibrate yourself for periods of sleep and periods of wakefulness, meals, and so forth. So this circadian rhythm, which certainly is strong in people, and we found out if it's regulated properly, it certainly is a healthy thing to do. It's part of being a healthy human being. And if you mess it up, then other problems crop up. Sleep problems, mental problems, perhaps physical problems. There is a lot of research on this subject now. It's been going on for some 20 years or more. And when I was with the Electric Power Research Institute, I organized one of the first, if not the first, symposiums that looked at the research on that subject. And that was published back then, still is available, I believe, so that you can see just what was going on. People were being measured in various ways to see how strong those sleep-wake cycles, those circadian rhythms were. And we began to make the relationship between those rhythms and the amount of light and when that light was applied. So there were really 4 factors involved. One was, when was the light applied? 2, for how long was it applied, the duration? 3, the intensity of the light. And 4, the spectral distribution of the light. In other words, which wavelengths of light were impacting the eye. And part of that research was that they found out that it wasn't the standard rods and cones of the eye that were causing this light energy to affect the circadian rhythms. It was some unknown types of cells that are in the eye that went directly to the brain and affected the brain in a different way that hadn't been understood before. In some respects, we still don't understand it all, but we do know this, that there's a spectral distribution of that light sensitivity. It peaks in the blue range of the wavelengths. And so if you properly control the spectral distribution and those other three factors, then you can entrain circadian rhythms. And what's happening today is that we're just beginning to understand the quantities involved. In other words, if I wanted to design a lighting system with circadian properties, I'd need to know those four things, or have to control them somehow. And the intensity of light, the spectral distribution of the light would be up to the light source manufacturer, the lighting fixture manufacturer, the installer, the lighting designer, and so forth. All those things have to be thought of if it's going to work. And we don't have all the tools yet in place to do that. But we've got more than we did have, and we've been able to put numbers on it for the first time over the past year or so.
So how long do you think it's going to be before we've really got our hands around that, or somebody can come out and say, this is what we need for a more healthier light?
Oh, I think we're there. I think if you're very careful now, you can do that. There are recommendations now that will lead you down that path. There are groups. There's a group called WELL that has promoted. They're on version 2 now of what they call the WELL Building Standard, which has circadian rhythms as part of the wellness of life, along with food and water and air and so forth. But light is right there, and they have a mathematical model that, if followed, they say will be good for the circadian rhythms. It will entrain circadian rhythms in the proper way. There's another model that was developed by the Lighting Research Center up at Rensselaer that is based upon a model that they call CS. And that also ends up with numeric values so that you can try different illumination levels or spectral distributions or intensities and be reasonably sure that those circadian rhythms are entrained based upon results that have come out of the research over quite a few years recently. And this research is ongoing, so we'll be knowing more as time goes on. And a particular area of concern that I'm involved with is lighting for the elderly. So we think that, and the initial research results show this, that you can improve the quality of life for elderly people or those people in nursing homes or bedridden perhaps, or perhaps in recovery after surgery by properly controlling the light amount and those other factors that I mentioned. And that will be a good thing. It will get away from this so-called perpetual twilight that many of us live under. Let's say if you go to the office in the dark in the wintertime and you live under very controlled lighting conditions, maybe no windows. If you don't get out at lunchtime, if you go home in the dark or the evening, you look at screens in the evening and you go to bed and there's light coming through the window. All of those things contribute to your light dose. And that may not be a good thing because, as I said right at the start, people need bright days and dark nights. We know that pretty much as a fact.
Right. So if you wouldn't mind, if you could send me the links to where, if anybody wants to learn more about circadian rhythms and how to build products more towards, those standards, if you could send me the links, then we can post those on our website here or on the podcast just for people's further information.
Sure. Glad to do that.
Okay. So I wanted to touch base a little bit on blue lights. I personally have heard a lot about blue lights in Hawaii or for dark sky or around Arizona and in those areas. Can you shed something on that?
Yeah, I'm actually thinking of writing a little column for the American Lighting Association about that as part of the technology series I do for them. Yeah, blue light's gotten a bad name for some reason. I think it's because blue light is where the maximum peak of sensitivity is for the circadian rhythms that we were talking about before. But there's always been this sense of blue light that it is more energetic than other colors. And indeed, it is, according to physics. But some kind of damaging properties, that's kind of a stretch. There is in the literature and in certain standards, safety standards, something called the blue light issue, the blue light hazard, which means that if you have a very intense beam of blue light and it's focused into the eye, damage can be done. Well, that's true of almost any color of light, but blue is a little more energetic, so it could be stronger. And that's regulated so that it doesn't occur in normal use of lighting. You would have to look in the blue laser for something like that to happen. And your body has a major light source that can damage your vision very quickly, and that's called the sun. If you look at the sun for more than a few seconds, damage is being done. And your body has, over the years, developed a defense against that. And you blink, you turn away, you stop that from happening in your retina, and it can be painful. So we have the same thing here. And it's not a hazard we don't understand. We do understand it. But as I say, the light sources are regulated. So if they are not in a certain class and classified as very safe, then they have to be labeled and instructions have to be provided on how you properly use those lamps. But in general, blue light is like any other light that you see, and most people are exposed to blue light under conditions in amounts that are very, very low. The amount of blue light that you receive from, let's say, an LED or fluorescent lighting system is very, very low compared to what you receive normally in daylight outside on a sunny day. So we're not in any imminent danger from blue light. That's the real bottom line. Unless you're doing something really different and really stupid, like, say, glancing into the light from a blue laser or other very strong focused light source. Light is safe. Light is a very safe thing to use. And electric light is well controlled from the safety standpoint, not just electrically and from a fire hazard, but also optically as well.
So let me just piggyback on the whole safety thing. There's lots of talk and articles about LEDs. Are they harmful to your health? I was reading some things earlier this week where somebody's report was, LEDs can cause this and this and this. And another report says LEDs, they're totally safe and they're not harmful to your health any more so than regular incandescent light. What say you about, are LEDs harmful to your health?
The quick answer is no. And that's backed up by a special report from the European Commission. And in fact, as I write this article that I mentioned, I'm going to quote that report. I'll certainly include a link for it in the links that I send you. But there's been independent studies of light from LEDs and other light sources over the years. And there's been nothing found in the light output from LEDs that is harmful either directly from the vision standpoint or to your health over time. If you sit in a dark room for weeks at a time, the lack of light is going to be a major problem. But it's very hard to overdose on light. Again, your body tells you if you're in bright sunshine and you get sunburned, you've done too much.
Right.
So you need to be wise about it and apply the proper light at the proper time. But we know what that is. We know what we need to read or to see. And those recommendations are standards worldwide. People aren't very different as you go around the world in terms of their lighting requirements to see. And so we've developed very sturdy standards on this subject. And I have not seen any studies which say that somehow light, unless it's used in very peculiar ways or very unusual ways, would be harmful to anybody's health.
Right. Let me change or switch the conversation over to regulations. A lot of different lighting regulations going on, and all of that. And right now the big talk is state of California and some of the things that they've got going on. State of California has two major lighting regulations that have basically has the same test requirement, yet do two different standards and probably two different groups that run them. And I'm talking about Title 20, Title 24. Do you ever see the agencies getting together on some type of a common ground?
Well, California kind of goes its own way there. They are driven, of course, by energy efficiency considerations. And they have over the past few years, as you say, in Title 20, which regulates lighting equipment and a lot of things about that equipment that go beyond energy efficiency. For example, color, flicker, and some other characteristics that occur in lighting, electric lighting. Those standards have been developed to more broadly because they also tried to include lighting quality considerations. In other words, if they regulated LED light bulbs, they had to be more than just efficient. The folks in California with Title 20 and Title 24 were interested in that people would also get lighting quality out of those regulations. And that was controversial because lighting quality is a little hard to define. What color rendering should we use, for example? In commercial industrial lighting, we use a minimum of 80 as a color rendering index, and that's 80 out of 100, where 100 is the maximum. I could make an argument for residential lighting that it should be at least 90. I mean, what better place to use good quality lighting with bright colors and high vision quality than in the home? So those numbers are always going to be somewhat controversial. There'll be differences of opinion, especially if getting better color means compromising somewhat on the efficiency or performance of some kind.
Right. Do you see any other states that are going to follow suit with California?
No, not in the way California has. And it isn't just California. Nevada has picked up some of the California regulations, and some of the other states, and I should say Canadian provinces too, have done some things to regulate more than just efficacy, lumens per watt of light sources. So there is quite a bit out there. There are some national regulations, and we are aware of those in the lighting industry, of course. Often we have input to them, but again, California was unique. The California Energy Commission, while there are plenty of open discussions there, they have pretty much paved their own way. The industry, I think, at times has felt somewhat left out of this. And yeah, the industry interests are very different, perhaps, than the commission's interest, but nevertheless, it would be good to work together more closely on this, doing what can be done at an economical price and with practical considerations of merchandising these products, getting them into the consumers' sockets or homes, making them part of the building trades easily, making them available. All these things need to be considered in this process, and that's been a area of work that has gone on between the industry and the code regulators, of course, for a long, long time.
Right. Just a couple of other things. I want to go back to ALA for a second. From a technical perspective, what does the American Lighting Association offer to its members?
Well, it's unusual. The ALA is vertically integrated, so its members include not just manufacturers of residential lighting equipment, fixtures, controls, and so forth, but also the rest of the chain. And that would be the fixture reps. It would be the lighting designers, often interior designers these days, who are doing residential lighting design. The lighting retailers are very important in this chain because they see the customers on a one-to-one basis. And so they interact and they get feedback on what the customer is thinking about, what they want to pay, for example, or what they would like to see in the way of products. So the ALA is in a position to use that integrated structure that they have to optimize the customer experience, to put products into the marketplace that meet the customer's wants and needs, and also, of course, to build a great industry where communication is easily and efficiently done. So when I joined the ALA, we were kind of limited to things like, well, we need technical people to check out the codes, to sit on code panels, to work with UL and Canadian Standards Association, CSA, and other code writing bodies so that we're represented and that we get good quality codes that everybody can use and understand. But as these new technologies have come along since I joined ALA in 2001, why it's broadened very considerably because there's so much new information. People need to know what an LED is, and for many years they needed to know, well, is an LED a better choice for this application, or a fluorescent, or maybe some combination? What fixture should I buy, and what are the characteristics of that fixture? Let's say, does it work in low temperatures or in wet locations, or what happens if it gets splattered by grease in a cooking area of a kitchen? So there's all this stuff that technically has to be considered in residential lighting, just like any other part of lighting design in many respects. But some of these things can be dangerous. Some can have hazards in fire and in electrical shock or safety of various kinds. So ALA offers to its members, and especially the smaller companies that maybe don't have staff people that have time to look into all of these things, it's a resource. And that resource is very important at making members aware of what's available technically, where the industry is going, what we are for, what we are against from a technical standpoint. We watch legislation, for example. We try to be at the table when the codes are written and discussed and input what we know. And many of our manufacturers, of course, have great laboratory and production facilities so they can actually do tests. A good example of that, by the way, is recently the Department of Energy, U.S. Department of Energy, has regulations for ceiling fans. And the question was, well, how do you measure the airflow of a ceiling fan? Now, that sounds a little bit silly maybe, but that's a tough thing to do. You have to set up a standard condition. You have to measure airflow in different locations. You have to do this over time in a space that is pretty standardized so you can repeat it in laboratories of companies all over and even overseas. And then the results have to come out in a way that people can understand them. So calculation of efficiency of a fan is tricky. And we're still working on standards for it. As many years as we've had ceiling fans and many years as we've had regulations for efficiency of ceiling fans, we still don't quite have it right. And so the DOE and the fan manufacturers, ALA is involved, very much involved. We're still working on ways to optimize the accuracy of such measurements for ceiling fans. And I think that'll go on for a while. And LEDs, it's the same way. What is the life of an LED? How long will it last? We hear numbers, 25,000 hours, 50,000 hours. I've heard 30,000 hours. Well, come on. Things don't usually last that long. How do we know that? They haven't even been around long enough to know to have burned that long.
Sure.
So there's extrapolation that has to be done. Who should do that? Well, the ALA works with the Illuminating Engineering Society to answer questions like that. And fortunately, the ALA, particularly in recent years, has reached out, and the board is fully supportive of this, as well as Eric Jacobson and the others of the staff, to reach out and set up relationships with other organizations so that we talk back and forth. For the first time in history, for example, the Illuminating Engineering Society put out a residential lighting standard, RP11, that was the work of both ALA and the IS. So this is an ANSI standard now. It's the best we know, the best we can do at the moment to represent residential lighting with all the quantities and all the design ideas, all the figures and facts that we know. And so that's the standard. And we're very pleased to have participated in that.
Right. And, I've been a member of the ALA for many years with other companies and with our
Yes.
current company. And I think the thing that's impressed me the most about ALA is that it is a resource. It is an invaluable resource. And not only that, even when we get into with the engineering subcommittees and all of that, and you walk into the room, it's one of those check your swords at the door type of thing as you walk in, because all of the competitiveness comes in, and you let down your guard, and you're there to help each other out because it's a common ground. And you don't see a lot of industries that are like that. Everybody tries to hide this and hide that, but I think the American Lighting Association has done a great job with that whole thing with breaking down the competitive barriers. So for that, I'm very, very grateful.
Well, I am too. I have to say, certainly that this has been one of the joys of my life. Is the engineering committee of the ALA is, as you say, it's a group of people to get together once a year and exchange emails and stuff on questions. They meet in code panel meetings. They have a chance once a year to review all of this. It is strictly non-commercial. We can't talk price. We can't talk trade issues. We have to talk about the science and the engineering, and it's really a rich source of information.
So, Terry, let's pick it up where we left off before. And I'd like to go back to ALA for a minute.
Sure.
And from a technical perspective, what does the American Lighting Association offer to its members?
Well, they do have members do have a special place with regard to technical information. Obviously, I'm hired to do that. And so technical support is a key element of ALA services to their members. And this is intended to go to all members, whether they're retailers or reps or manufacturers. And of course, it manifests itself in a couple of ways. One is telephone and email support, but also, of course, the engineering committee, which is a standing committee of the ALA. And that means that we can draw on other experts who have volunteered to help us with things like codes and standards, technical questions from consumers, problems that manufacturers may be having with measurements. A whole host of things come up. And we've used that capability mostly with working with DOE, EPA, California, of course, with Title 20, Title 24. So we put together little task forces sometimes. There's a ceiling fan task force, for example, when DOE put up proposed regulations. So we could review those and get back to DOE with comments in an organized way. So this is a big deal. And of course, my favorite part of it is the ALA engineering meeting each year, where we get together for a couple of days and we talk about technical matters that affect the residential lighting industry. And we have presentations, often with outside people who are really experts in it. Like last year in our August meeting, we had Naomi Miller from PNNL, DOE, and she talked about this whole general question of flicker, which is characteristic of LED lighting systems. And it can't be measured very well, but it's very important if we're going to have quality lighting. So we learned a lot from that. And each year I try to have a theme or a focus point to get that information out.
Okay. Do all these outside organizations, Department of Energy, Energy Star, and all that, do they listen to us? Do they listen to the American Lighting Association?
Yes, they do. ALA is a strong voice. We have good consumer information, and if there's any question about that, we bring out the surveys that we do periodically, where we ask people what they expect from their lighting, what are they interested in knowing about, what kind of lighting do they like, how do they buy it. A whole host of questions in there that really tries to get into how they feel. And yeah, these are marketing studies, but it's amazing how many agencies, state, local government agencies, don't really know this. They get feedback, of course, but they also get feedback through legislators and others who are involved, and things get muddy. So I think they count on ALA to give them a report on what ALA's customers and members are feeling, and that's a little different, and it's often helpful. So
Sure.
it's an important part of the whole feedback process of how the system's supposed to work.
Right. And as I've mentioned before, one of the things that I have always liked about being a part of the engineering committee is that, you've got, 20, 30 people coming in from, all different industries, from light bulbs to fixtures to
Mm-hmm.
the regulatory agencies. And that's really an opportunity. And people do a good job of, checking their swords at the door. And
That's
all,
right.
all barriers come down at that point, and we're all there to help each other out, because we're all there to try to understand what's going on, because we don't all understand 100%. But then we go away, and myself, I'm not afraid to call any of the people from that committee, and maybe talk a little bit further about a particular topic that I didn't understand. And everybody has always been super willing to help out and go the extra mile. And so that's just an excellent, forum, to meet all of your peers and, just help everybody out.
Well, I'm glad you said that, because that's really the objective. And yeah, we pay attention to things we have to pay attention to, and they're kind of prioritized. Um, and ALA, of course, is close to NEMA, the National Electrical Manufacturers Association. Some of our ALA members are also NEMA members, so we try to keep in touch with them. They're bigger than we are, much bigger, but they're also more specialized, and particularly with some of the lighting products that they members of NEMA have. So we try to keep a good relationship there, and it's a source of information. It also helps us with major industry matters that, for example, trade rules and tariffs and things like that, because NEMA can take a position. They're well respected in the industry too, and we can often work together with them on that, or sometimes we go it alone. So we really try to work on each other's strengths. We try to make use of each other in a good way to get things done that we think are very important for the industry.
Right.
And
And American Lighting Association is also a member of a lot of these other organizations, like the National Electric Code, and there are members from the ALA that actually sit on the National Electric Code and help write those codes, correct?
yes, that's right. The National Electric Code is a good example. Of a great process that has worked well for a long time and has given us the safest electrical systems and products in homes in history. We have 2 permanent members that sit on the code panels. They represent ALA. They're designated, and they're 2 because if one can't make a meeting or gets sick or something, why the other one can fill in. They go to meetings several times a year to review the proposals, to work with the other members of the panel to get it done. And every 3 years, a revised National Electric Code comes out. And these code changes reflect things that we see going on, new technology, for example, or concerns about safety in certain areas, or maybe changes have to be made because they're not well understood by electricians or electrical contractors working out in the field. So there's always something to do, but that has given us a code. And I should also say this works in Canada too, because we also sit down with Canadian Standards Association and the code writing people up in Canada and work in the same way for the Electrical Code of Canada. So it's a lot of responsibility and a lot of time. But again, our ALA members who are representing us are great volunteers, and we appreciate that.
And one of the nice things about the ALA is if you have an issue with something out in the field and you don't know who to turn to, people generally turn to the American Lighting Association for direction. And just as an example, and I don't know how much this comes up anymore, but you'll have an electrical inspector who won't accept a certain certification listing. And it doesn't happen very much anymore, but it has in the past, that they won't accept a Intertech or an ETL label. This isn't a UL listed type of a product, and it's
That's
just
right.
like, how do we get this resolved? We've got this building that's going up, and you've got one electrical inspector that's saying, no, this isn't a listed product. And who better to contact than the American Lighting Association to help you with guidance and to help resolve those types of issues?
Well, hopefully that's one of the best things that we do. And you're right, it doesn't happen very often, but every couple of years, or maybe I better say it a different way, because involving Canada, we usually get involved in things like that 2 or 3 times a year, where a local inspector, as you say, may raise a question about a certain installation or product. And then we go back, we talk to our code panel representatives. We'll generally get somebody like a certification body involved, and that could be UL or Canadian Standards Association or any of the other labs. And if their label isn't well known, yes, that's very important to get them involved. And often then we can go back out with the support of those labs to where the problem is, talk with that person, make sure they're aware of the latest updates in the news and so forth. And that really helps. We've resolved several issues that way. In fact, we've got one going on right now up in Canada. And so far, so good. These are reasonable people, and they want to do the right thing, not just cause trouble. They want people to be safe. So we're all for that, and we're really ready to support the labs and the other members of ALA who make that all happen.
Sure, I can't imagine trying to resolve something that on my own.
Yeah, that's right. When you're all alone out there and the inspector has laid down the rule, it feels a little bit frustrating and helpless, but that's where ALA can come in and do some good.
Right. So what do you see as some of the biggest challenges that we face in the next 2, 5, 10 years down the road?
Well, it's no secret the lighting industry, both residential and commercial, have been changing very dramatically. New companies are springing up. Some of the old ones have disappeared. Mergers are occurring daily. So it is a time of change, and I don't think that change is going to slow down anytime soon. One big trend is this, that ALA and other organizations are reaching out and setting up relationships so that we can work together better. For example, ALA has a relationship with an organization called CABA, C-A-B-A. And CABA is all about smart products and smart homes. And we, as ALA, participated in one of the CABA research projects called Smart Home as a Service, which has just been completed, and the final report is due out. Several ALA members were sponsors of that research, as was the ALA itself. And so right now our job is to get that report, get it out to our members, explain it as best we can, call upon the resources of CABA to help us with that, talk to the researchers, and figure out what is the market for smart home products, especially those that involve lighting. Lighting and controls, shading. Shading's become a part of the lighting industry now because daylight is after all a light source. So it's working more with other organizations that have knowledge and information that would be helpful to our members to provide good lighting and to strengthen their business. So ALA is all about that, and I think we're on the right track. But what it means is we're not in a silo anymore. We're not holed up all by ourselves talking to each other. We're really reaching out to different parts of the global industries that serve the consumer, the homeowner. For example, we're very close with the Consortium for Energy Efficiency. Their members are electric utilities. They're going to have smart home programs. We need to know about those because they're going to go to the consumer the same way we are. Well, maybe there's some synergy there. So Eric Jacobson and I talked to the board of CEE just a few weeks ago, and we talked about things like that. How do we work together? How do the utilities make use of ALA member showrooms, for example, if they have energy-saving products that they'd like to put into place? All of these things are possible, but only if you reach out. You can't just stay talking to yourself and expect this to happen.
Sure. We've talked now for probably close to an hour, and we've covered an awful lot of topics, some technical, some historical, of where the lighting industry has been and kind of where it's going. Is there anything that I missed or that you would like to share?
Well, just one thing, that lighting is historic. It's needed by everybody. It's an essential part of our society. But lighting is more than providing light so that you can see. It is decorative. It has an aesthetic element. Now we're finding light health is becoming important. We need to know how to apply light in a positive way. There are other aspects to lighting that we don't understand very well, such as germicidal use, for example, keeping our homes healthier. There's going to be a great development in that. So lighting is branching out. It's not just the light bulb in the center of the room so you can see where the door is or the bed is. It's really something that's part of your environment. And we need to understand that. We need to support it. We need to innovate. We need to work with others. So that's where I see the real future of this industry and lighting to be.
Right. Well, Terry, I can't thank you enough for coming on Light It Up podcast. There's several topics here that we've talked to that we can branch out and probably talk for hours on. But I just appreciate you taking the time with us, and hopefully this will, answer a lot of questions. Maybe a lot of people will have questions that they want to reach back out to us. But that's what this is all about, is trying to explain, the lighting industry, and the future of it. So again, thank you very much, Terry. I appreciate everything.
Well, you're most welcome, Tom, and thank you for putting some things in place like this podcast to get that word out. We certainly appreciate that, and we wish you good luck in that endeavor.
Great. Thanks again.